Quantum theory, the laws that govern the very small, particles, electrons, and so on, and general relativity. Stephen is looking for a single theory that explains all the forces in the universe. I work in something called string theory, which we think is a theory of everything, the theory that eluded Einstein, the theory of everything. When I was 8 years old, something happened that changed my life entirely. All the newspapers ran a picture of a scientist's desk. The caption read, "A great scientist could not finish this book." On the desk was a book, and the caption continued, "The greatest scientist of our era could not finish this book." I was fascinated. What could be so hard that a great scientist could not finish it? Why didn't he ask his mother? Why didn't he go to the library and just look up the answer? Over the years, I went to the library, and I found out that this man's name was Albert Einstein, and that book was The Unfinished Theory of Everything, an equation no more than 1 inch long that would allow us to, quote, read the mind of God. Well, we think today that we have it. It's called string theory. I'm the co-founder of one of the main branches of string theory, string field theory. But it's too difficult to solve with the human mind. We have the equation, but the equations are so powerful that we cannot solve them analytically. That's why I got interested in quantum computers, because quantum computers may be powerful enough to solve the theory of everything and give us an understanding of why we had the Big Bang, why we have a universe, why we are here. We may be able to answer that question with a quantum computer. What if everything you knew about the universe could be tied together with a simple thread? A thread so minuscule, yet so profound that it weaves the very fabric of existence itself. This is the enigmatic world of string theory, at the heart of quantum physics. String theory challenges our traditional understanding of the universe. It presents a framework where tiny vibrating strings replace the particles we once thought were the smallest building blocks of matter. These strings, oscillating in multiple dimensions, could potentially unite gravity and quantum mechanics. Imagine all the forces and particles, all the mysteries of nature, coming together in one harmonious symphony. In this journey, we'll unravel the strings that could tie together the biggest puzzles in physics. Stay with us as we venture into the uncharted territories of string theory and explore the secrets it holds for our universe. The more we learn about the universe, the more we realize how simple it is. A handful of equations. For example, the equations for light. I was fascinated by this. You have Maxwell's equations, an equation again that is about 1 inch long, that allows us to summarize everything we know about light. Then gravity. Einstein worked out his equation, which is about 1.5 inches long. And so I said to myself, I want to work on a theory that will get an equation no more than 1 inch long that allows us to summarize the electromagnetic force, light, the nuclear force, and the gravitational force. And the leading candidate for it, though we're not positive that it's correct yet, is something called string theory. As a culmination of my work, I wrote down an equation, 1 inch long, that summarizes all of string theory. It's called string field theory. That's actually my equation. Of course, we can't prove it yet. It would require an atom smasher millions of times more powerful than what I had in my garage. But we think that one day we'll be able to prove that perhaps string theory is a theory of the universe. If the theory is correct, it means that music is a paradigm that eluded Einstein. All the particles we see are nothing but musical notes on a tiny vibrating string. Each vibration corresponds to a particle. That's why we have so many particles. So what is physics? Physics is the harmonies of vibrating strings. What is chemistry? Chemistry is the melodies that you can play when these strings interact with each other. What is the universe? The universe is a symphony of strings. Imagine if the universe were like a grand symphony and all matter and forces were mere notes played by incredibly tiny strings. Each vibration, each oscillation, forms a melody of existence. This is the idea behind string theory. Instead of viewing particles as points, string theory sees them as one-dimensional lines, like the strings on a violin. Each vibration of a string is like a different musical note, creating various particles. But it's not a simple melody. These strings vibrate in multiple dimensions beyond the three-dimensional space we perceive. Imagine a tightly wound piece of yarn unfurling to reveal hidden layers and dimensions within. It's a dance of dimensions that could provide answers to the most fundamental questions about our universe. Yet, not everyone is in tune with this cosmic concert. Critics argue that string theory is more mathematical art than observable science. Despite its beauty and elegance, it's been called a theory of everything that seems to explain nothing. Some scientists say that it lacks empirical evidence, making it untestable. It's a theory that stretches our imagination, but leaves us grappling with doubts. Is string theory the ultimate truth of our universe? A musical masterpiece weaving reality? Or is it a sophisticated illusion, a tantalizing melody without substance? Well, I've seen a lot of theories come and go. When I started working on string theory back in 1968, when string theory was first born, it was the bad boy of physics. What? Strings? That violates everything we know about particles. What? Strings vibrating in 10-dimensional hyperspace? Beam me up, Scotty. We're talking about science fiction. Hyperspace. Wormholes. Other dimensions. That stuff was right out of science fiction. But yes, string theory talks about that. In fact, we're up to 11 dimensions now with string theory. Most people think that the universe is three-dimensional. Length, width, height. 3 numbers define where you are. Einstein came along and said, no, there's a fourth, time. So, given length, width, height, and the time of the measurement, you now have an event in the 4-dimensional space-time continuum. That was Einstein's idea. Now, we realize that Einstein didn't go far enough. There are other dimensions. In fact, we think there are up to 11 dimensions. That's really the universe of the Big Bang. The Big Bang was a disturbance in 11-dimensional hyperspace, and we are nothing but 4-dimensional vibrations that peeled off from the original explosion. When this idea was proposed in 1968, people said, "This is nuts. We live in 4 dimensions. We live in a world of particles. You're talking about strings, music, hyperspace, wormholes. Come on, give me a break." Well, now we are in a position where we dominate a lot of physics departments. So when I hear criticism of string theory, perhaps string theory is too powerful, I say to myself, hey, look, if you can't stand the heat, get out of the kitchen. That's just the way cutting-edge physics is done. At the cutting edge of physics, all theories are subject to blistering criticism. If you can't stand it, get out of the kitchen. String theory, though enigmatic and elusive, has not been without its triumphs. It's more than a theoretical curiosity. It's a vibrant field that has shed light on some of the universe's most profound mysteries.